I've had a request to look at number 11 from 4.4. This one's on page 289, and it's a word problem. So the word problem that's in question is talking about a Canada Day celebration in Surrey. The firework is projected vertically into the air and reaches a maximum height of 100 meters. The path of the firework is parabolic. So the best thing to do to get kind of an idea about this, because what they really want is they want you to figure out an equation, is to draw it. So if I were to draw my little grid here, and this is my 0, I'm going to put the information in that they give me. So they say it reaches a height of 100 meters. So my height's going to be here because I'm actually making a graph of what it would look like. The distance from the beginning is, it says it's 30 meters. So let's just put 30 meters out there. So basically what you're seeing is the firework is going to go up and down. And it reaches a height of 100 meters here, but that's not the vertex. The vertex would have to be the x-coordinate and the y-coordinate. If it's a parabolic path though, and it started at 0 and it ended at 30, halfway in between is going to be my axis of symmetry and also my x-coordinate for the vertex. So that's 15. So you could try doing fancy math and stuff, but if you actually just draw it out, then it kind of becomes logical to follow this way of thinking. So now we have a vertex, and we have a couple of different points. So what we can do is put in what we know into the formula. Our formula, just use a less obnoxious color here. Maybe I have one. Y equals a times x minus p squared plus q. Now, I know that this is going to be 15 because it's up there, and this is going to be 100. I don't have any other points on the graph besides the zeros. I'm not going to use 0, 0, that's no good. But what I could try using is 0 and 30. So 30 and 0, right? Because this point here is 30 and 0, that's my x and y. So I plug that in, 0 equals a times 30 minus 15 squared plus 100. Now I have an equation where I only have one variable, and therefore I can solve for that variable. So the plus 100 comes across, I'm going to subtract 100. So I get negative 100 equals a times 30 minus 15 is 15, squared is 225. So I could actually just write 225 a like that. That makes it easy. And therefore I could just divide, because this is being multiplied. So I move the 225 over to here. All I'm left with on this side is a. And if I were to reduce this, I can obviously see that 25 is a factor, because 100 has a factor of 25, therefore 225 does as well. So I can take that out, and if I go 200, well, 25 goes into 100 4 times, there's 2 of those, so that's 8, and then another 25 is 9. You could use your calculator if you want. And it's still got the negative sign on it. So then a is negative 4 over 9. So then I'm just going to rewrite this equation because it's a little messy here. But I'm just going to substitute negative 4 over 9 in for a. Follow the same pattern, x minus 15 squared plus 100. So I've used algebra by plugging in an extra point to get my a. And I've used a sketch of what actually happens and turned it into a graph to find my vertex point, which I've plugged in. And now I have a formula that is follows the pattern of y equals a times, or sorry, I don't have to repeat that, standard, the standard equation. There it is.